So today we're talking about the volume of revolution. Okay, today you'll be able to find the volume of a solid form by rotating a figure about an axis, more specifically the x-axis. Okay, so to start this whole thing off, the definition of a solid of revolution is basically it's formed by rotating a plane figure about an axis of revolution. So basically what you're doing here is you're taking a curve, okay, a curve that's graphed, and you are literally taking a part of the graph and you are rotating it around the x-axis, okay? And I have a picture that represents that. All right? So consider the curve of y equals, just take a look at this for a second. I'll give you guys a second to write this down, okay? So say you have the curve of y equals the square root of x. Okay, that's this curve right here. And we want to rotate it about the x-axis. So we're going to take it and we're just going to rotate it around and around and around. Can you guys visualize this happening? Okay? So it's not flipping, it's literally going here and then rotating all the way back around and around and around. Okay? Crazy what I do. Okay? You are creating a circle, but since it's basically creating a three-dimensional circular figure, in other words, a cylinder. Okay, so the solid that's formed is called basically a disc, and the disc is cylindrical in shape. Okay? So you're finding the volume of that cylinder. You can, I don't know if you guys can add this to your notes if you would like. I just wanted to give you guys that visual. Okay, I wanted to give you guys that visual. So, when you're finding the volume of revolution, you have this formula here, okay? If y equals f of x, so that's your function, is continuous on a particular interval from a to b, and the region that's bounded by the curve in the x-axis is rotated, then the volume of the solid form is given by this equation right here, where the radius of the disk is f of x, whatever the function is. The height of the disk is dx, and the volume of the disk is represented by the volume formula for a cylinder. So we're going to look at an example. Here's the first one. Yes, it is a lot of writing, but we only have 7 pages today. So we're going to use the definite integral to find the volume of the solid formed by the region f of x equals the square root of 9 minus x squared. And the x-axis is rotated 360 degrees about the x-axis. So the key thing here is we're going to find the volume that you get by rotating this function about the x-axis. So we have our formula for volume, which is pi, the integral from a to b, of our function being squared. That's key. You are squaring your function, and then dx. So it's pretty simple. It's pretty straightforward. You have your function, f of x, so you plug it in. And then you square it. The one thing that we don't know here is what? B and A. Now, B and A still represent the bounce, okay? So where the curve hits the x-axis. So, what does this look like? Yes, what type?
It's going to be like
Somewhat. We're going to do this one non-calculator. So, how do you figure out where this graph crosses the x-axis? X-intercepts. Find out where it equals 0. So you can plug this in. I'll plug this in.
3, 0.
Set this equal to 0. Square both sides. Subtract. So they are what? Positive 3 and negative 3. So we're going from negative 3 to positive 3. So it hits here and here. This graph's going to be helpful for us when we do the part where we verify using geometric formula. Okay? So when you square a square root, what happens? It goes away. So we basically have pi, the integral from negative 3 to 3 of 9 minus x squared dx. I think you guys can take it from here, yes? To find the integral, the definite integral. Okay? No calculator, so leave it in terms of pi. So figure this out. evaluate that from -3 to 3, you plug in 3 first to get 27 minus 9. Then you subtract what you get when you plug in -3, which is going to be a -27 plus 9. Okay? So this is basically going to be 18 minus a -18, which is going to give you 36. Now you still have a pi that was on the outside that I forgot to bring down. So your answer is going to be 36 pi. That is your volume for the solid being rotated about the x-axis. Okay? Questions? Now we're going to verify this using geometric formulas. Now, in order to do that, we need to figure out, okay, well, what does this graph look like? We know it crosses at -3 and 3. Okay? If I plug in -2 in for x, what do I get y to be? Square root of 5. Okay, it's not so nice. What happens when I get 1? When I plug in 1? Square root of 8. Still not nice. What happens when I plug in 0? You get 3. So that's a nice number. If I plug in 1, I get
Square root of 8.
square root of 8. We plug in -1. And if I plug in 2, you get square root of 5, right? So this basically forms a half circle. And so if I rotate it about the x-axis, Michelle, what you say?
A sphere.
It's going to be a sphere. Okay? And when you rotate it, it's going to form a sphere. So when we're going to verify this using geometric formula, we're basically going to look at the volume of a
4/3 pi to the third, right?
4/3 pi.
Or pi squared. Or is it pi third? It's 3.
It is 3. What's the radius of the sphere?
3.
3. What's 3 cubed?
27.
27 divided by 3 is? 9 times 4 is?
36.
Wow, that was so much easier. Can we just do that?
If it does form a geometric shape, you can. However, if it says use the definite integral, then you need to use definite integral. Yes?
Sorry, I'm confused. What were you plugging into when you were like talking about that?
Okay, to get the purple curve, we basically plugged in -1, -2, 0, 1, 2 into our original function to get an idea of what the graph looked like, because no one can tell me what this graph looked like. So don't forget, you can always default back to the old school table option to get a graph of your curve. So that's how we're able to get that half circle. And so when we rotate it around the x-axis, it forms a sphere. It forms a solid ball that has a radius of 3. So to verify that our answer is 36 pi using geometric formula, we're going to find the volume of the sphere that it formed. And so that's where the 4/3 pi cube came from. And then we plug in 3 because the radius of our sphere is 3.
How do you always use the like? How do you put the one plug in one for the x?
When I said plug in 1, that was just so we could figure out where the points were for the curve. But since when you plug in 1 for x, you get the square root of 8, and that's not a nice number. And we're not using our calculators here. I know it's going to be less than 3, but more than 2, because the square root of 8 falls between square root of 4 and square root of 9. So I knew that it was going to be less than that. You guys try the next example on your own. Okay? You need to know the shaded region. And the shaded region is right. Okay? So you're going to use the definite integral. No, sorry, the definite integral to find the volume of the solid formed under the region between 0 and 2, and it's rotated, an extra A, about the x-axis. And you're going to give your answer in terms of pi. Give you guys about 4 minutes, 5 minutes. All right, so the definite integral is from what to what?
0 to 2.
0 to 2. Then what?
X squared inside x squared.
X squared being squared. What am I missing?
Pi.
Pi in the front. So when you square that, that turns into the integral, pi times the integral 0 to 2 of x to the 4. That's what you're taking the antiderivative of. So it's going to be 1/5 that you're evaluating from 0 to 2. Of course, there's still the pi on the outside. So when you plug it in, 2 to the 5th is,
32.
so you have 32 fifths minus 0. So your answer is just 32 pi over 5.
6.4.
Okay, is it 32 pi over 5 the same thing as 32 divided by 5 pi?
Not divided by.
No, not divided by 5 pi.
Divided by.
32 divided by 5
You just
times
quoted the
pi.
wrong thing. It's 32 divided by 5
You
times
said
5.
pi was supposed to be on the bottom of the fraction,
No, I didn't.
therefore it
What if you
means
just leave pi like?
I just erased it so I can't show you, but I didn't.
Yeah, or you
I
just
said
do
you pi on
32.
my- Look,
over
look,
5.
watch this, watch
That's
this.
what I
Oh,
did.
look at that.
Because pi is technically 3.14 over 1.
Yeah.
So if it went anywhere, it would go to the top. Last one, this one is pulled from an IB, okay? Test. Do write it down. It's a little long, okay? And then I want you guys to answer it, okay?
Well, I haven't read it yet, but it's not hard.
Alright, and that might be hard to see, but that does say e to the x divided by 2. Okay? So, go ahead. I'm going to give you, I think this question was, well, you guys got to write it down, so I'll give you about 2 minutes. Alright, so this particular problem says the diagram shows part of the graph of e to the x over 2. And there's your curve, there's your shaded region. It says find the coordinates of P where the graph meets the y-axis. This is an easy problem. Now this is, again, something pulled from an IB exam, okay? So it assess other concepts in one, okay? So how do you find the coordinates of P? You plug in 0 for x. When you're looking for where it meets the y-axis, you're basically trying to figure out where x equals 0. So you'll have this. Anything to the 0 power is 1. So the coordinates of P is what?
0, 1. Yeah,
Zero,
I
one.
got that right.
Okay? It said coordinates, so you need to have 0, 1. Not just y equals 1, but 0, 1. It said coordinates. Questions on that? Okay, so that was like the very first set of topics dealing with algebra and functions. And then it says the shaded region between the graph and the x-axis bounded by 0 and ln of 2 is rotated through 360 degrees about the x-axis, basically what we've been dealing with, okay? Write down the integral that represents the volume of the solid obtained. What is the integral to find the volume? Pi,
0 to the ln of 2,
0 to ln of 2,
e to the x over 2, all that squared dx.
okay?
Do we have to simplify further to e to the 2?
I would, just to be on the safe side, I can't remember what the mark scheme said, but I would just be on the safe side because when you square this e to the x over 2, what happens?
E to the x.
It just becomes e to the x. So this is really the ln from 0 to the ln of 2 of e to the x dx. Okay, that is the formula for volume. Pi, the integral from from a to b, so 0 to ln of 2, your function being squared. Okay? So now we're going to show that the volume is pi. Now when you show a problem,
Small steps.
you show your steps.
I got
Okay?
it. I can't read them, but I got them.
It doesn't
If
even
I can't
count.
read them, then how am I supposed to grade it?
Well, you know that I did them.
So, you basically take the integral of e to the x. What's the integral of e to the x?
E to the x.
E to the x. So you'll have pi e to the x, and you evaluate it from 0 to the ln of 2. Then you plug in. Don't skip any steps. You plug in the top bound, and then you subtract it when you plug in the lower bound. Well, what happens with e and ln? Cancel each other out. So this turns to pi times 2, or 2 pi. What's e to the 0 power? So you have pi. So 2 pi minus pi is pi. How'd you guys do?